Our grouping exercise is going to consider University of Arkansas data. So we're going to be looking at Dillard's department stores. Well, these are located throughout the United States in kind of mid to large-sized urban areas. But we have to state, however, that the market potential of those stores varies greatly. So now the quest of ours is to see how the Dillard stores that are specialized in the high-end department store goods might have greater market potential in a higher income, more urban, more educated areas. And we're looking forward to analyzing those groupings. This is our input data. The store MSA is basically a store number. DD census region is your south, north, east, so forth in the United States, to be coupled with latitude and longitude information from the store. We furthermore have 3 bits of information on the stores: the income of its population, the percentage of people who have higher education, and the percentage of people who have bachelor's degrees. So this is basically the input data we're using for grouping those Dillard's department stores, and we will be using k-means clustering, the second algorithm, with the SAP GUI. We're now going to access again University of Arkansas data. We have opened up the SAP Logon program, which is under academic software in the PH 353 class, and let's create a kind of a username that will last longer, or a logon that will last longer this time. So I'm going to right click on connections and do an add entry. I'm going to name it, let's say arbitrarily, just UARK, something like that, University of Arkansas. And the application server, once again, was sapprt.walton.uark.edu. The instance number was 01, and the system ID was WBI. Now, I can click on Finish by now, and it creates this logon nicely for me, and I can just double-click later on UARK, and it's going to log me on automatically or get me to the username insertion. So now I'm going to insert my username and password. So this is the second time we're doing this. And the first thing to do is to go to Enhanced Analytics. We go to Enhanced Analytics, and we have to do both the data mining models and model the analysis process. Let us first go to Data Mining Models. For that, I'm going to right-click and do a Execute Data Mining Models. It's going to open up everything here, and you see that clustering is under its separate subsection. So let's select clustering, and now let's select right-click Create Model. The model name, so it might be MKTG 663 underscore UBI underscore clustering model. I'll put the name model there as well. Remember, there were processes and models, and I'll put, just in case, a number 1. I'll name the description in the same way, and actually manual is going to be good for us this time as well. So let's click on OK. Next up, we will have to add all those fields one by one now. So I'm going to click on plus. It's going to let me add a field. Now the name. And then I'll just basically enter a name, description, info object for every one of them. Remember that the info object has to be very precise. So it's going to know what this data is about in the database and what's the length of the data field. I mean, is it the numeric stuff and how many numbers are in there, or how many information units are in there? So let's get going. Store data, the first thing. It's a store number, and store data is the info object name as well. And as you can see, it recognized it as a character. This content is a key field. which means basically that we're going to identify all the stores into which cluster it goes, into which group it goes by its store number. So we'll gather all the store numbers into a cluster and into another cluster and into a third one. Okay, another plus, and the next one is longitude. Okay, it says that it's FLTP length 8, and it's going to be, and now that's important, it's going to be continuous. When we see a discussion about similarities in the third learning module on recommender systems, we will be seeing that we measure distances between, let's say, point A and point B by just looking at how far they are from each other. In this case, the continuous means that they really are like, let's say, one longitude might be 100 and another might be 120, and the distance between them is 20. We will see that there will be some discrete data here as well. The discrete data is actually the last data bit we'll be entering, which is census region, which is kind of north, south, east, west, which as you can see, cannot be measured very straightforwardly in distance to each other. So there comes some difficulties that we're introducing for k-means clustering, but let's get to that later on. Next up, latitude. Let's enter this. As someone said in the session, it's going to actually put those letters into capital letters automatically, but I just did it explicitly so. And latitude is once again a continuous field. Let's enter now population, which is ddmsa underscore pop. ddmsa. Okay, here it is. And this field is continuous. So it's just basically a number. We can measure the distance between two numbers. Now high school percentage. ddmsa high without an underscore. Feel free to go straight to the end and just copy the results that I've written in here if you don't want to watch this like real time. This field is continuous as well. The next one, bachelor education percentage. So it's ddmsa batch, just all one letters, all one word. And here it recognized this one automatically as well. It's a decimal number with 9 length. And it's a continuous one. Next one up is census region. So this is dd cens reg. Since the second letter is an S. And here it made it automatically capital. And this field is discrete. So it's either north, south, west, east, something like that. Next up. Now we'll have to configure k-means clustering given our knowledge about what it does. So let's go to parameters first. And under parameters, we have number of clusters. Let's say that 10 is good for us, so we will be trying to cluster the stores into 10 different categories. Maximum number of distinct values allowed. So this pertains to discrete data, like our census region. It allows maximum of 25 of those different discrete values. That's because you might think that if it's a difference between 100 and 120, which is a continuous value, and south and north, which is a discrete value, that the difference between south and north will be easier to calculate than the case of continuous data, but actually it's much harder. So it kind of has to look through all those combinations. So that's why we don't allow for too many number of discrete values. It's going to just slow down the process. Maximum number of iterations. So this is how many times it can, in a maximal way, regroup from one k-means cluster to another, closest one to the next cluster, recalculate the cluster center, and again repeat closest one to the next cluster, and so forth. So that's the number of iterations. Let's leave it at 10 right now as well. And minimum factor of intercluster hops. So this tells us that 0.1% has to be hopping to another cluster for it to continue. So this basically tells us that the algorithm will let go at a certain point when the results are already quite stable or quite staying the same. So you see a lot of parameters. We have to know a few things about k-means clustering to work through it. Let's go to fields. And under fields, we also have discrete parameter. For a discrete value census region, we have parameters, the weight, how important it is. So we can even let's say if point A is at 120 and point B is at 100, and now point A weighs twice as much, then the center of those points is not going to be at 110, but it's going to be 1/3 of the way from 120 and 2/3 of the way from 100, which essentially is 13 comma something. So we can even make them weigh differently. Default value. Well, very often we have that, so to say, problem with missing data. So we have something that's kind of just left blank in the database, and here we can fill this up. There is a totally separate field of investigation, which is called imputation research. So that's how to kind of create those missing values in a very meaningful way. Now, right now we don't have missing values, but we could have put a default value in there. And binning intervals is again how many folds is a let's say difference between latitudes. How many folds is it divided into? So a few parameters here. The same parameters actually go for, I don't know, for instance, for high school percentage, and we don't change anything. We don't change anything in here. And now we're done. We're ready to run the model. Let us now run the model. Or rather, activate it. It finds that everything is okay with it. Okay. We're now going to be creating the analysis process. Remember that we now have to move up the hierarchy here. So we need to go to Exit, press that. Now we're where we choose clustering. Another exit. Now we can choose the model the analysis process. So into that, execute the model the analysis process.